Welcome to the Tech Ed Podcast, where we visit with leaders who are shaping, innovating, and disrupting technical education. People who are not afraid to think differently, not afraid to try something new, all with the goal of securing the American dream for the next generation of STEM and workforce talent. What happens when we combine a passion project with entrepreneurship? Today's guest, Bre Pettis, is a name that may be familiar to many individuals in our audience. Bre was the co-founder of a company called MakerBot, and he co-founded a company that brought 3D printing, additive manufacturing into the classroom at an incredibly affordable price, brought that company from 3 people to 600 people. Well, Bre recently founded and is CEO of a company called Bantam Tools. And Bantam Tools is democratizing the world of machining and bringing CNC machines into the classroom in the same way that MakerBot brought 3D printers into the classroom, and making it an affordable endeavor for schools and educators across the country. In doing so, he is unleashing creativity on the part of students, and not just our traditional tech ed students, art students, STEM students, students in the Fab Labs, students in the CNC lab, and allowing them to bring projects from ideation and creativity all the way to physical presence. And in doing so, Bre is inspiring the next generation of makers, of artists, of manufacturing talent, and engineers. So please join me in welcoming to the Tech Ed Podcast, Bre Pettis. Bre, thank you so much for being with us.
Thanks, Matt. Pleasure to be here.
And it's a pleasure to have you. Let's break the ice a little bit here with one of those classic icebreaker questions. I want our audience to get an opportunity to get to know you. I know you're a fascinating individual. Let's start out with one fun fact that folks don't know about you that would just kind of explain everything that is Bre Pettis.
You know, I think the fun fact is that I got my start doing puppetry. I started doing puppet shows and then just through sheer luck, ended up finding myself at Jim Henson's Creature Shop making animatronic rubber gorillas.
Wow. That is something that many of us don't know. I will tell you that is the second time that I've had an animatronic conversation over the course of the last 2 weeks. We actually have an intern that works in one of our businesses that was out in California learning all about animatronics, came back with just an unbelievable bird that she had made that, I mean, was so realistic. It was absolutely crazy. So that is something that I wasn't expecting. That is something that our audience probably didn't know about you, but upon thinking about it, knowing that you were into puppetry, that's where you got your start. And along with Jim Henson, famous, of course, for all the incredible work with the Muppets, somebody that we lost way, way, way too soon years ago, but a true genius. And I think we're going to see the genius in a lot of the things that you're doing today as well, Bre, as we dive into some of the things that you have going on. Before we get into Bantam Tools, before we get into all of the amazing creativity that can go on in our classrooms, I want to talk about the classroom just in general. Now, you got your start in some ways in the classroom as a teacher. I want you to tell our audience about your teaching experience and what was it that you saw through teaching and through working in and around the classroom that you thought perhaps was missing and maybe inspired you to go on and do all the amazing things that you've done.
I was a public school teacher, a K-8 generalist in Seattle Public Schools, and from 99 to 2006. When I went to school, in my middle school, we had a wood shop and metal shop. And by the time I arrived as a teacher, those programs didn't exist anymore. In fact, because I had a background in puppetry, I ended up getting a job teaching art. But because I was a generalist, it was sort of like, we're going to give you 3 periods of art and 1 period of writing and 1 period of math. And I'd be like, fine, fire them. Give me what you got. And but my classroom was actually a former metal shop. So it still had the brakes in it, still had all sorts of infrastructure in there from metal shop. I think the 90s sort of was a slow degradation of the trades and wood shop and metal shop, and frankly using your hands. You really had to focus on schools having to focus on reading and writing and teaching to the test. And I was lucky enough in the art part of my educational career to sort of be outside of that world because I hadn't figured out how to test art achievement. Hopefully they never will, right? But primarily I taught the kind of students that are normally somewhat neglected in our school systems, the one that that are kinesthetic learners, the one that learn by doing, the one that do things with their hands, the one that want to see the product of their time. So I warmed up to those students. So
Absolutely.
those are my students.
Well, our listeners will see a lot of Matt Kirkner and what you just said, being a hands-on kinesthetic learner, because we talk about that all the time. And that was my challenge all the way through school, and I did fine, and I did what I was supposed to, and I went on to post-secondary education, and I don't regret any of that. But man, what a grind having to sit in a classroom and listen to a teacher over and over and over again, hour after hour, class after class, day after day, year after year. And I felt like I was emancipated the day I finally graduated and could get out in the world and just work for a living and do things, because that's exactly how I am. And I am a hands-on kinesthetic learner. I learn by doing. I don't learn by sitting in a lecture hall. Some people do. That's not me. I have to learn by actually doing it. And what you just talked about was exactly the way that I learned. So that was music to my ears. You didn't teach music, or at least I didn't hear that you taught music, but you did teach. Let me get it right. You taught art, writing, and math in a former metal shop, in a school, in a former shop room. I almost envision those press brakes sitting there ready to be used, maybe lonely, maybe feeling a little bit forlorn because nobody was using them again in the 90s. But that is the true definition of STEAM in so many ways. We talk from time to time about science, technology, engineering, art, and math, and you literally had, in a manufacturing environment, teaching art, teaching writing, teaching math. That's just absolutely fascinating to me. Very, very cool. And it really speaks to, I think, something that I think a lot about. I'm a bit of a musician, actually. I love that aspect of art. I love music. And I think quite a bit about the convergence between the world of manufacturing and the world of art. I think sometimes we don't give those two worlds enough credit for how similar they are. And I can tell you from all the years that I worked in manufacturing, 20 plus years as a manufacturing CEO, a lot of times there's as much art and creativity and design that goes into the perfect manufacturing process as there is engineering. Do you see it the same way? Are you seeing that convergence?
I do. And I think some of the best engineers have to be willing to do absurd things. And being in the arts teaches you to try and push the boundaries of things, right? So I believe very strongly that innovation and the absurd are very close to each other. So sometimes if you need to innovate, you can do just something completely weird, and it might not get you where you want to go, but you'll probably learn something that you can bounce off of in an innovation space.
That's fantastic. I have a really, really good friend who was a teacher at the Art Institute of Chicago for a number of years. And when he would begin his courses, so his brand new students, first year students, the first thing that he would tell them, and I just love this, he said, "You have gone through your entire life with people thinking that you're a weirdo, and I'm telling you that you are now here in a place where it is entirely appropriate and entirely okay to be a weirdo. Be comfortable in that little bit of absurdity, as you point out." And I think that's just a really, really cool way to look at the world of engineering, is the creative side of things. Be a little bit absurd, be a little bit crazy. You look at geniuses like Elon Musk, like him or hate him, the guy is incredibly creative, and he's incredibly bizarre, but he's doing really, really big things without a question. Speaking of doing big things, you did a big thing in terms of creating a company that I think many in our audience are going to be familiar with. If you're in the world of STEM, if you're in the world of Fab Labs, MakerSpaces, creative spaces, you're probably familiar with the company that our guest co-founded. Bre Pettis was a co-founder and ran and led a company called MakerBot. So what inspired you, Bre, to develop this technology and launch that company?
So I had moved from Seattle to New York, and in Seattle, everybody has a garage, but in New York City, everybody's got a closet, right? So I needed to make things because that's just what I do, and ended up putting together a community called NYC Resistor, which is essentially a clubhouse with a bunch of hardware nerds with all the tools we could possibly need, and also all the resources together with other people there to essentially make anything. And out of that, we wanted a 3D printer. At the time, like the entry level, Stratasys Dimension 3D printer was like $65K. And we figured we could make one. And when we put it together, we were like, this is about $1,000 in parts. Maybe we should start a business. And we originally thought, okay, this is so weird. There's probably just going to be a couple of other nerds like us who want this. So we'll make a kit and we'll sell a couple and we'll do it on the side. But right away we sold, we made 20 kits, and we had thought we'd have enough for months. and they sold out essentially instantly. And we were like, okay, now we're in trouble.
Right.
So yeah, out of the makerspace that we created, we were able to have the resources to make 3D printers, and we had a laser cutter. So all the enclosure was made out of everything we could was made out of, laser cut 1/4-inch plywood. So those were sort of very garage days of making stuff in the garage and making it work.
Do you long for that a little bit? Do you miss that?
I grew MakerBot from, 3 guys, a laser cutter, and a dream to 600 employees. And there's a number of stages at which a company sort of goes through a phase shift, right? So at about 25 people, you have to go through a phase shift, and sort of not everybody can know everything at that stage. And sort of things get sort of, you're going to do this and I'm going to do this instead of we're all going to do this together. At about 100 people, you're like, okay, now we have like multiple teams, and you're like multiple, and so you're split up there. And at 600 people, I think there's some number at which you don't know everybody's name, and 600 is definitely near that level of it's hard to, you can't know everybody in your organization at some point. So with Bantam Tools, I've been pretty intentional about growing it. We're under 30 people now. I'm fine growing with demand, but I'd like to keep it under 100 people if possible.
Yeah, I hear you. I've run companies big and small. I've been involved in organizations big and small. I actually worked for a governmental entity that had tens of thousands of employees for a while, all the way down to little small startups that have a few. And I've found my niche in being a part of I kind of say like a Navy SEAL team. Give me a small group of people that's trying to do huge things and can be extremely effective, can move really really quickly, can change course. I like working in a small to mid-sized business where, as I put it, you can come up with an idea on Monday, implement it on Wednesday, and start to see the results on Friday. That doesn't happen when the ship gets really, really big and you've got to steer it, and you see what happens with the decision you make today may manifest itself a year from now. So I'm with you, and there's benefits to both, and certainly growth is probably the most important part of that for me. Is that great people want to work in growing companies, and if you sit still for too long, they'll go find someplace else that's more interesting. So it's really important to make sure that the organization is dynamic, and I know that's what you're doing at Bantam Tools. And I want our audience to learn a little bit more about Bantam Tools. What are the machines, and then really how do they foster and inspire creativity and design skills among students?
So at Bantam Tools, our customers are split in half, right? Half of our customers are innovators. So you mentioned Elon Musk. We send a lot of machines to SpaceX and Tesla, NASA and Draper and all sorts of places. People who are building the Mars rovers and all sorts of interesting innovators get the Bantam Tools desktop CNC milling machine, and then educators get it to train the next generation. And it's pretty much split half and half. We're a little bit of a multiple personality in that way, where we have like some customers who are like, need to make something to go on a spaceship tomorrow. And then other customers who are like, I need to figure out how to teach my students how to be ready for tomorrow. So on the education side, it's all about making things accessible, friendly, and affordable, right? So with MakerBot, we took something that was really expensive. They were like refrigerator-sized machines, and we made them microwave-sized and affordable. With Bantam Tools, we're doing the same things. If you've ever seen a CNC milling machine in action, they're usually between 10 and 20,000 pounds. They're the size of a small room, and you could crawl into one, and it could be like a spare bedroom in some cases. And we make a machine that's 80 pounds. 2 people can lift it on a desktop and use it and learn how to use it, and then put it away when they're done. So for educators, this is great because they get to get students access to it. And it's also, with those big machines, when you break them, it can cost thousands of dollars to fix them. And our machine is very hard to break. It's possible, but it's very difficult. We have a high-speed spindle that runs at 28,000 RPM. So we're primarily letting the spindle pull itself into the material rather than having to brute force it into it. So it's the forces on it are less than the big machines because we're using high-speed machining. And the cost of the bits is smaller. So instead of costing $100, it'll cost like $15 or $20. So a mistake can be much more affordable, which is great for teachers. It just means they can give their students access without without a lot of anxiety or stress.
Let's unpack that just a little bit. So I heard desktop milling machine, CNC machine. spindle turning 28,000 RPMs, which for those that may be a little bit foreign to the world of CNC and to CNC milling, it's industrial grade machining. It's not some toy that you're putting on a desk. I mean, that's getting pretty close to the real deal, if not right at the real deal. So talk a little bit more about, you said 80 pounds, two people can lift it on top of a table. What kinds of projects are the students working on? What does that experience feel like?
So there's a couple of places we fit into educational systems. The obvious one is the robotics team. If you've got a first robotics team, those teams have to make a robot. They're given the challenge, and they don't have like a lot of time to prepare. So they have to get up and running. They have to make a robot that does a number of things, and they have to design it and make it. So if there's a robotics program in the school, we zoom right in there. If there's an engineering program in a school, we zoom right in there, both in the high school and the higher ed side of things, because one of the things that engineers get criticized for is they make things that can't be makeable, right? And they're like, but I made it in CAD.
Right, yeah. Design for manufacturability is a real thing.
Yeah, so it's also really awesome for engineering students to go the full spectrum from idea to finished part. They learn so much from that jump from CAD to CAM, which is computer-aided manufacturing, the programming of the machine, to getting to the actual finished part of the machine, making it and then holding it in their hands.
Very, very cool. You're right about the FIRST Robotics teams. I love seeing the creativity that goes on in FIRST Robotics. I can see this in certainly in a Fab Lab, in a MakerSpace, in a pre-engineering course. I mean, there's just so many different applications for this technology. And one of the things that impresses me most about your technology is how closely it aligns to that industrial experience, but does it in a way that isn't necessarily intimidating, is very usable. Students aren't going to be afraid to press buttons for fear of breaking a large machine, to your earlier point. I think one of the other things that really, really impresses me is the integration of the FANUC CNC control. I know that's not the only option, but it's a key option for your product. Talk a little bit about why it was so important to you to integrate the FANUC CNC control into the Bantam Tools machine.
So we were at IMTS, which is the every 2 years big hoo-ha in manufacturing, where everybody goes and sees all the new stuff. And at this event, we really wanted to find a partner that we could, because our customers were asking for an industry standard control. The Bantam Tools control is fantastic. It's ultra affordable. It's easy to use, but it's, I built it from the ground up, so it's not industry standard. There's a couple of beautiful things about the Bantam Tools desktop CNC powered by FANUC, which is, first of all, it's just a beast. We used FANUC servos on this for the drive, and they just don't make servos for our size of machines. So it's like completely overpowered. It's like, rah. So the thing is just a beast. And then the great thing about it, having the FANUC control, is it's industry standard. You can train up the students on our machine, which is not indestructible, but nearly indestructible. And if something goes wrong, it's very affordable to maintain. And they can beat it up, where if you have them working on a robo drill or something like that, that can get very expensive if there's a screw up, right? The other thing is that it's just more affordable. So you can get more of them. So more students can get access to getting trained up on industry standard controls. And so we're seeing in places where they need to get people trained up quickly and they need to do a lot of people in parallel, this is the solution for them.
I've actually been in Japan in the manufacturing plant, the FANUC plant. You've been there as well. And so I was there in 2018 and I was there in 2016, I think, were the last two times that I went, seeing that plant where they're building those servo motors, watching FANUC robots make FANUC robots, which is simultaneously amazing and scary, but really, really cool. And so just really impressed with that partnership that you have with FANUC. FANUC doesn't always say it, but I'll say it. It's about 2/3 of CNC controls in industry here in the United States are FANUC CNC controls. That's what we ran on our CNC machines. And so when a student goes into manufacturing, there's a really good chance that they're going to see a FANUC control on that machine. Doesn't mean that they won't see some other controls, but odds are they're going to be around FANUC. And so awesome that students are getting that exposure, getting to understand what CNC machining is all about, inspiring them toward new careers and really doing it in a creative way with creative technology. On this topic of creative technology, Bre, I mean, what a creative combination that you've had in your experience. You start out in the world of additive manufacturing. We used to call it 3D printing, of course, and now we call it additive manufacturing. And then you migrate over to this world of CNC, of subtractive manufacturing. So instead of building a part up from the bottom up, we're basically taking a piece of metal or some other material and machining that, milling that into the part as it's going to look when it's done. So talk to us a little bit about about the combination of additive and subtractive. You were obviously at MakerBot was additive manufacturing, Bantam is subtractive manufacturing. How do you see these two technologies as complement each other in the classroom and in industry?
So additive, subtractive. So when I started MakerBot, people would ask me what it was, and I'd be like, it's a 3D printer. And they'd be like, what's that? And I'd say it's like a CNC machine, but the opposite. Instead of cutting things away, it builds it up layer by layer. And now with MakerBot and the sort of the universal deployment and adoption of 3D printing, I can explain CNC the opposite way by saying it's like a 3D printer, but the opposite. Instead of building things up layer by layer, you put in a block of material and cut it away. So there's a couple things that are great about CNC that you don't get with 3D printing. With 3D printing, you get ease of use. You can just throw a model at it, and the likelihood that it'll work is pretty high. Whether it will be the exact measurements that you expect it to be, whether the holes will be the diameter you want them to be, they probably won't be on the first try, but you can actually work to get there. And depending on the type of 3D printing you're using, you're going to have different you're going to hit the target better or worse on tolerances. With CNC machining, we just dial that stuff in. So when you make something, we hold 2 thou across 6 inches, which is, I'd love to say 1 thou across 6 inches, but our build volume is only 7 by 9 inches. So, and it's repeatable. So if it's a smidge big, you can make it a smidge small in your model and do an offset and you're good to go. So the ability to do very high tolerance work, parts that fit together perfectly or have to work in a mechanical contraption, CNC is just great for that. And also if you want to work in metal, there is 3D printing metal, but it's still there. It's basically a foundry. And so you're dealing with a lot of shrinkages and a lot of challenges around things. It's still very difficult and very expensive. So if you want to make parts out of metal, CNC machining for the win.
Yeah, absolutely. And the combination, and in some cases we may have applications where additive or 3D makes more sense than CNC and vice versa. And you even hear stories in some cases about people 3D printing a part and then machining it afterwards, and you get the best of both worlds. And by the way, you don't have to apologize for holding 2 thou across 6 inches in a desktop milling machine that's going into a high school. That is amazing. Very, very impressive, which really speaks to the industrial nature and the quality of the product and the experiences that students are going to have. One of the knocks that I've had on Fab Labs and MakerSpaces over the years was making the connection between what students were doing there and what they would see in industry. And I toured back in my industrial days a lot of high school classrooms, a lot of as tech ed was starting to come back, a lot of tech ed spaces and so on. And they'd say, this is where we're teaching industrial manufacturing. And I would look at it and say, look, there's a lot of really cool things that these students are learning here, but I'm not quite sure how well we can make the connection, especially at that time, from what they were doing on maybe a vinyl cutter to what we were doing in a metal fab shop or a machining facility and so on. So talk a little bit about kind of the makerspace and Fab Lab space, an area that you're really, really familiar with, and then why it's so important for students to have access and exposure to industrial grade CNC in a desktop environment as they go through their education pathway.
I wish in some ways I could go back into time and be a young person today, because there are these maker spaces in schools and they attract the students who need them, right? And the students who go in there, if I go back to my younger self and walk into one of these places, it'd be like a kid in the candy store, right? Like if you have a maker space and it's got a 3D printer, a laser cutter, and a CNC machine, and usually they have other stuff too, like a sewing machine and other type of hand tools. Wow, you can get even though it's not necessarily everything that you might use in manufacturing, you can just go so far with that toolbox, right, in a maker space. Even at Bantam Tools, when we do new things, a lot of times we'll be like, okay, we need a new part. quick, let's just mock this up, throw it in the 3D printer. An hour later, we're like, okay, holding something in your hands is really different from how it looks on the screen. You're like, oh, we need to put a hole here. Oh, we need to attach this here. So I think in terms of the makerspace world, frankly, having a Bantam Tools desktop CNC milling machine, there isn't really any competition in the space at the price point and the quality and the obsessive engineering you get out of our machine. So it just adds the ability for students to have access to making parts out of metal. It gives them the ability to use systems that they're going to use when they go into industry, right? A lot of folks don't realize that you can go into, a program to learn manufacturing, and most people think, oh yeah, that's for that's not going to be, go be a doctor or lawyer instead. But there's people who aren't going to be doctors and lawyers, and you know what? Manufacturing can pay really well for people who have that aptitude, and they find it in maker spaces. They find the aha moments of, oh, this is for me. Oh, that's where my talent is. They have those moments in maker spaces.
Sure that students are getting exposure to this kind of technology in addition to some of the more traditional Fab Lab and makerspace technology. I know that's something that's near and dear to your heart. You've talked about this goal of taking really complex, really expensive manufacturing equipment and boiling it down to systems that students can get their hands on, that they can work very closely with, that are affordable for a classroom. Why is this such an important endeavor for you? Why do you think so much and put so much effort into, I'll call it the democratization of CNC and industrial manufacturing equipment?
It goes straight to my heart, right? So I believe really that it's really important to do things in your life that can have multiplier effects. That and on an individual level, that can mean learning new skills. You don't know what you'll use those skills for in the future. At a makerspace level in a community, you don't know what kind of ideas or businesses might grow out of that, or what kind of skills will get developed and careers that will unfold from that. In an educational infrastructure, teachers just have this as who they are. They're investing in tomorrow. They don't know what these students what they're going to be up against, what kind of challenges they're going to have, but they know that if they can support their growth, that they can take it to the next level, and magic will happen in the future. It's similar with Bantam Tools, where we make these machines. We don't know what a lot of our customers do with them. I mean, we send them to some of the coolest places in the world, both as academic institutions and as innovative institutions. And we don't often know what the innovation that people are doing with them, but we know that the future depends on it. So for me, where we're going with why do we do what we do? What does the future look like? I think starting for me as an educator in the early 2000s and seeing the potential in my students, and then joining the maker movement. I worked for Make Magazine for a couple of years and then Etsy, and saw the sort of personal empowerment that people could have when they could unlock their skills and potential with machines that were normally in factory far away situations that were too expensive for anybody to have access to. This idea of bringing everything in, democratizing it, making it accessible, making it friendly, making it easier to use. It just gives so many more opportunities for people with a good idea or a solution to unleash that solution onto the world. So that's really why I do what I do. In theory, I could be doing a lot of things, but I love to build infrastructure for people to solve problems that we don't even know we have yet.
Well, and you think about the leverage that comes from unleashing that potential, and the fact that you can inspire maybe 20, 30 kids in the classroom a few times a day, or you can build systems and learning opportunities that really inspire and unleash their creativity across an entire generation of students. And it's got to just kind of give you goosebumps a little bit to think about as your company continues to scale. And I'm sure you felt the same thing at MakerBot, thinking about the huge numbers of students that are benefiting from these opportunities, and really in your own way that could be fairly significant, changing the world. Is that the way you think about it? I mean, I'm not trying to pump up your ego too much, but it's got to be a really good feeling to know that you're affecting that many lives.
There's a numbers game in there that's very satisfying, as you said, but I will say, I probably interacted with six to 700 students in my educational career. And that's the biggest impact I made in the world, was in my teaching career. So for the educators out there, I would just say I just want to be encouraging because they're the ones who are having the biggest impact on the future. And so often teachers just, it's hard to be a teacher these days with the current state of the world on many levels. But at the core, folks who are in the classroom at any level are the ones who are doing the true investing in the future and having the biggest impact on what the future looks like. So I want to just push it right on to the teachers.
Fair enough. Yeah, you won't get any argument out of me. So 700 students, do you stay in touch with any of them?
I get pinged kind of regularly. People are like, "Oh, Mr. Pettis, do you remember me? You had me, you taught third period art." And I'm like, most of them I do remember. And this was a while ago. So they're all not just like, they're not just adults. They're like grown adults with children now. So it's been a minute. But yeah, I think about those days fondly.
Absolutely. Just a tremendous number of lives to impact. And thanks for putting the credit on the teachers. Certainly, like I said, you won't get any argument out of us here at the Tech Ed Podcast. They're a huge reason why we do what we do. And certainly with your background in the classroom and being able to relate directly to what it's like to be a teacher, 20 some years ago, or maybe 15 years ago and now today. And it's changed even in that period of time. There's no question about it. So credit to the teachers and thanks for sharing that.
I will say, though, I think it is a very exciting time to be a teacher and interfacing with kinesthetic learners. There's more infrastructure now for educators who have kinesthetic learners in their classroom to allow them to succeed. There's more and more school districts are figuring out that if they have MakerSpaces in their schools, that those students get traction there, and that if they turn on the teachers who are kinesthetic learners themselves and allow them to use their talent from a place of leadership, that just, I think most schools have a teacher who is that nerd, the shop person who loves tools, who loves to make things. And they may be an English teacher, but they're the one maybe teaching the after school course in 3D printing, or they're running the robotics club. And there's so many more opportunities for those kind of teachers to just rock it in their career.
Absolutely. Release their inner STEM teacher, their inner tech ed teacher, and it doesn't matter what discipline that they're coming from. And we've seen a lot of that as well. I mean, some of my favorite stories over the course of the last few years have been students that maybe were in more traditional STEM disciplines. Maybe they were teaching math or physics and found their way into tech ed and delivering learning. I mean, we talk about convergence between art and manufacturing. There's huge convergences between STEM learning and engineering, between MakerSpaces and Fab Labs. And now you start introducing concepts like smart technology, smart sensors, smart devices, all the AI, all the data science, and the way that we can bring those technologies and those advancements to bear in the world of engineering and design and manufacturing. We're going to start to see that there's less and less of a line, I think, between some of the traditional STEM disciplines and the hands-on opportunities for students. And so, credit to you for pointing that out as well. This opportunity for teachers, regardless of what they're teaching, to really dive in and show that there are great hands-on kinesthetic ways for students to learn all kinds of things.
I think there's something else that's exciting about the current time we're living in, which is, before the pandemic, if you had used the word supply chain, very few people would have known what you were talking about. But now everybody understands supply chains. They understand how they get disrupted. They understand what needs to happen to keep things moving along so that we all have food to eat and things and the things we need in our lives. And I think that a lot of value I think there's a lot more value today for people who are in manufacturing, just an awareness that it exists, than there were even 5 years ago. So there's some momentum. So my hope is that the educators out there, the administrators are out there, are seeing that this is a trend, that it's worth investing in, that they can jump in and prepare this generation to do all sorts of things, right? To be ready for the next challenge.
100% agree. As someone who spent all those years in manufacturing, I've said more than once that I think one of the silver linings, and there weren't a ton, but one of the silver linings of COVID and of the pandemic was that people now have an appreciation for manufacturing and distribution and supply chain, and when we could get what we wanted, when we wanted it at a price that seemed reasonable. It was really easy to take all of us in manufacturing for granted, and then all of a sudden, when you can't get that, it's like, oh, domestic manufacturing makes sense. Maybe we should think about having manufacturing closer to the point of consumption. Maybe we shouldn't have products that are sitting out in the middle of the ocean waiting for a dock to open in California. And we're seeing public policy now standing behind that with huge investments in technology and huge investments in not just on the education side, but in advanced manufacturing and EV and obviously all the investments in microprocessors and in manufacturing plants for those technologies. And so I think it's a great time to be a teacher. It's also a great time to be in advanced manufacturing because of all those things. I think the next 10 to 20 years are great time to be doing what you're doing. Great time to be doing what we're doing here at the Tech Ed Podcast and having such a fascinating conversation with you, Bre, about all these topics. I want to just circle back for a moment a little bit to something that we talked about already, being your experience as a teacher and your experience in the art room. 3 periods of those 5 that you were teaching art. I had a really cool experience within the last year. We were up at Kohler Company, and I think most of our audience will be familiar with that company from the name on the fixtures in their bathrooms, in their kitchens, on their generators, and so on. Kohler has an artist in residence program that is absolutely fascinating. They literally have artists that are working out on the manufacturing floor, and they have access to their die casting equipment and access to machining equipment and doing it right in the middle of a manufacturing plant. And it was just fascinating and a real moment for me to just see in real time with my own eyes how similar art and manufacturing can be. And I've had this thought for a while about, when we first started talking about STEAM, when we added art in some cases to the word STEM, it felt a little bit to me like maybe the art people were just trying to get their hands on the money that everybody was putting into STEM. And then you start thinking about all these convergences and opportunities, and it makes you wonder if there isn't an opportunity to find students who are excited about art and draw them into the world of advanced manufacturing because of those similarities. Do you see it same way? Is there an opportunity to do that?
Oh, we are so aligned on that. Yes. So I've got a two-part answer for that. So the first one is this last summer I did an experiment where I created something called the Center for Machine Arts, and we did 2 cohorts of artists in residence for a week each that culminated in a show. And I reached out to artists that use machines to make their art and got them all together. And we had a fantastic experience where they learned from the Bantam Tools crew, they learned from each other. We had a fantastic week, both weeks. And then I'm going to do this again next summer because it was just so fantastic. And then, the arts are very core to who I am in terms of how I see the world. So the other thing that we've got going, which is really it's purely a passion project, honestly. And it's set up as a gateway into the world of computer controlled machines is I love pen plotters. So I grew up I went to engineering class in high school and we had a pen plotter. And maybe, 15 years ago, I got an HP plotter off Craigslist or something like that. And then just in 2019, I sort of got the bug and I started collecting HP pen plotters from the 1980s. And these things are amazing. They're so fast.
So just really quickly for our audience members, I know exactly what a pen plotter is, but for those that may not be completely familiar with what you're talking about, but just paint a picture of what a pen plotter is.
So a pen plotter was a peripheral, an accessory for a computer before printers. Right now we print something out and the printer just prints it out. But before there were printers, there were pen plotters. And these are robots that move the paper forward and back and move a pen left and right and up and down. And they do drawings. And originally in the Apple II and Commodore 64 days, which I'm 50 years old, I've just aged myself there. They were used for like making overhead transparencies or handouts in meetings, and you could, and it basically would write or draw for you with a pen. And
right, engineering drawings too.
Engineering drawings, architecture drawings, all this kind of stuff. So HP in the 70s committed to this as a peripheral, and they knew they were going to sell millions of them. And I recently reached out to all these engineers who worked at HP in the 70s and 80s, and they're just superstars. They're heroes to me. So anyway, long story short, about a year ago, I started wanting. I've hoarded all the HP plotters that have arrived on eBay in the last 5 years. So I have them all from the last 5 years. And they're such amazing machines. I want other people to have access to them too. So we're just getting ready to wind up a Kickstarter, and then they'll be available on our website to make a pen plotter. And it's just an 8.5 by 11 machine that does, or it's 8.5 by 11 paper, and it's a little bit wider than that, and it moves the paper back and forth. And it is an ultra fast, high speed pen plotter. And then we've got it connected to the internet, so there's all sorts of features that you can subscribe to different artists and download their art and plot them. And it makes art made with a pen, so like a real drawing made with a pen instead of a printout of a drawing. And their artists love them. So we're getting ready to wind this up and launch it. And it's also for the manufacturing geeks out there, it runs on G-code. So for those educators that want to create a portal for their students, I love CNC machines. I love 3D printers. I love laser cutters. All of them have a certain threshold where you have to learn a bunch of to make sure you can make your things safely. A pen plotter, teachers have access to reams of paper, and teachers have access to pens. And that's all that's required for this machine to get a student making G-code physical in the world. So for drawings, for engineering drawings, for creative drawings, all that kind of stuff, I really don't mind where the student has access to a pen plotter, but I know it's going to be like it's going to be a portal into the world of machining. It's going to be an entryway, an initiation into computer-controlled machines.
No, absolutely. As you were talking about that, I was thinking, I'm like, man, full disclosure, we actually had a pen plotter in our basement when I was growing up. So my dad was in a job where we had one. And I remember the smell of the ink and the pens and the little kind of that little noise that that it would make when it was moving itself around and doing its drawing. That's really, really fascinating and ahead of its time technology. And as you were talking about that, Bre, I'm like, I don't know why anybody didn't think of that. What a great way to teach Cartesian coordinates, and what a great way to teach programming, but you're teaching it in a way that is, completely aligned to the world of art. Very, 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 very fascinating technology there. And do you have a name for that product yet, by the way?
The Bantam Tools pen plotter. We like to keep things simple.
Awesome.
So
yeah, so I like it, and I think we might have just announced a brand new product here on the Tech Ed Podcast. So thank you for that. We're proud to be the platform for that announcement, and look forward to that new technology. What a great conversation we're having with Bre Pettis, who is the owner, the founder, the CEO of Bantam Tools. And Bre, we've only got a few moments left, but I do have one last question that we love answering every single one of our guests here on the Tech Ed Podcast. And that is, if we could go back in time. So you're 16 years old, you're maybe a sophomore in high school, give or take, and with your whole life in front of you, a startup like MakerBot, growing it to 600 people, having no idea that that's in your future, perhaps. But if you could go back in time and give one piece of advice to that 16-year-old Bre Pettis, what would that be?
I mean, I think, being 16, it's just being young is so hard for anybody. I think I'd first say, hey, it's going to be okay. It's going to be okay. And, I would give myself some advice I was given later, but I would give it to myself earlier. So later on in life, I was given some advice to follow my heart, follow my instincts, look inside to see if something feels right. And if it does feel right, go for it. When you find things that you love, commit to them. I figured that out later in life, and it served me really well, but wow, I wish I could have that earlier in life. So I'd basically front load that advice that I was given later in life, and I would give that to myself earlier. So believe in yourself, trust yourself. When you have choices, feel how they feel. Don't just think about what other people think is the best decision. Think about where it is in your heart.
Think about where it is in your heart. This whole idea of democratizing this manufacturing technology has a really important place, I think, in your heart, and a real important place in the American classroom and classrooms all over the globe. Bre, really great advice that you would give into yourself and that you just gave to our audience here on the Tech Ed Podcast. I want to thank you for taking time with us today. Just a fascinating conversation, covered tons and tons of ground, and I can't tell you how much we appreciate having you on with us today.
What a pleasure to be here. Thanks, Matt.
Thanks for joining us for this episode of the Tech Ed Podcast. If you haven't already, subscribe, leave a review, and if you like this episode, share it with a friend. New episodes launch every Tuesday, so listen in next week.